Welcome, welcome. We're going over some publicly available free response questions for AP Physics 1. This particular one is all about graphs and forces. We will start with a graph. They're giving us the graph for position, vertical position. So just tracing this graph, what do we see? In the first, I would say 8 seconds, we have a consistent slope that is positive. So we are moving at a constant velocity, and we can actually calculate that velocity if we know the slope. This goes from 0 to 12 meters in 8 seconds. So that's 12 to 8, that's 1.5. So for the first 8 seconds, we're going at 1.5 meters per second. Then within the next 2 seconds, look what we have here. This looks like a slope is decreasing. That's deceleration. Can we vouch that that is a constant acceleration? Not really. So let's proceed cautiously. We're not going to just do a straight line to represent a constant acceleration. And then we have rest right here. So velocity is going to be 0 between 10 and 18 seconds. From 18 to 20, this is speeding up. So speeding up, is it at the constant acceleration? Not sure. But it's definitely speeding up, and it's in the opposite direction, right? So we made a U-turn right here and started speeding up in the opposite direction. Looks like we went from 12 to 0. So 0 minus 12 in 5 seconds. All right, so that's negative 2.4 meters per second. All right, so the first 8 seconds, as we figured out, it was 1.5, 10 to 18, and then from 20 to 25 seconds, we are at negative 2.4. All right, there we go. And then in between, we're going to do a little bit of a squiggly line. This is our connect the line, so to speak. So this graph represents the same motion as the graph for position. Moving on, they're asking us to figure out the average acceleration between 8 and 10. We went from 1.5 to 0 in 2 seconds. So it's going to be negative 0.75 meters per second squared. And they're asking us to show the acceleration on the elevator in BII. The elevator is going upward, so it's a downward acceleration like so. They want us to figure out the apparent weight of a person. That person is inside the elevator, specifically at 4 seconds. At 4 seconds, V equals constant. Acceleration is 0. Then this little dude has gravity and normal force equal to each other. And normal force is the apparent weight. So it's just going to be 70 times 9.8. They give us that the person's mass is 70. So it's almost like 700 minus 14. So it's going to be 686 newtons. Or you can just go ahead and do 70 times 10. They'll take it. 700 newtons. That's perfectly acceptable. Unless that elevator is accelerating up or down, it's going to be just the regular weight of a person. That concludes this example. If you have any questions, comment below. If this was helpful, like, share, subscribe, be kind.